Hello, hello, hello. My name is Moises Trejo, and today we're going to go through one of my projects and I'm going to explain how I built it, how the code works, and all that fun jazz. So, today we're going to do particle interaction. So, if I click particle interaction, it's going to load in, as you can see here. It goes to just an S3 bucket. I host all of my P5JS projects on S3 and like I can just access them right here. So what does this app do? If you click, it puts a bunch of particles. This looks super weird. They're all moving super slow, but if I increase the frame rate, you can see that the particles, like once they get close to another particle, an edge is created and it's thicker if they're close together. But you can also increase the length at which these particles are created. So if I had a bunch more, you might notice that the frame rate is getting slower. This is because there is more particles and there's more calculations that the program has to do, which we'll get into right now. So I am going to move my screen for the third time, which is awkward. But if I inspect element, I just right click and click inspect. I can see here, I can go to sources to see what files are being used, and I can expand it. We'll just have this in the background here, but it's not really that important. So this is all the code. It's really not that much code. There's two important parts to this. P5JS runs on a game loop, which is different from like an events-based program. And a game loop, there is a function that is called every 60 times a second. So it does like a calculation 60 times a second. It does something very often, so that like you can experience it. I don't know if that made any sense, but yeah. So what do we have here? Length is 500, width is 500, particles is an empty array, and slider is an empty variable, and time is 0. This is also, by the way, some old code that I wrote. This is very old code, so it might not be the best, but we're gonna have some fun. So setup runs once in the beginning, so it creates a canvas with the window width and the window height. So this is just P5JS library. It calculates the window width and the window height, depending on how you load it. So if I make it this big, the screen will stay that size. If I do this, initially it will calculate the size of the screen and then keep it that size. Not really that important. You can dynamically change the size of it in draw, but I didn't really do it here. So then you fill 240. That's the background. Then I do no stroke. This is just how to draw some elements. Then I make one slider. Slider is equal to create slider at position 0, 100. Oh wait, no. It goes from 0 to 100, and then it starts at the value 50, and then it's positioned at position 20, 20. So 20 to the right and then 20 down. Then slider B, which is a terrible name for a second slider. I didn't even initialize it. I don't know how this works. I guess it just inferred that the scope is like global for this value. So slider B is equal to another slider, 1 to 70, and it starts off at 1. This should be renamed frame rate slider or something, but it's also positioned. Then draw. This happens every time. So every time we make the background black, every time we redraw something, and then it fills white. Then it writes length here and frame rate here for the labels. So it fills in. It says make whatever I do white and then print these every time. So if mouse is pressed, this is just a boolean. If the mouse is pressed and the particles that length is less than 300, if we have 300 of these. Don't add any more. I imagine. Oh, there we go. It stopped. And if mouse X is less than 200 and mouse Y is less than 100. So this is basically saying add a new particle if the mouse is pressed down, and if we already don't have a ton of particles already, 300 to be exact, and if the mouse position isn't here in this upper right corner, basically, because I guess you can't add any particles here. I remember adding this because it was annoying to like move the sliders while there were like things being popped up here. So I was like, okay, just only make it so that you can't add it within like a certain window, which makes sense. So every time check if the mouse is pressed and add a particle if you want. So for I is equal to particles length minus 1, I is greater than 0. This is a loop that starts at the end of the particles and goes to the beginning. Particles I dot connect. What does this do? It does dot connect, which I believe is a function here. So for every function, do dot connect. What does dot connect do? It gets the max of slider value, and then this is a poorly named variable. I had to check what it was. So this is the length. So it's from 1 to 100. So max is some value. So for all the particles, again, loop starting from the back for some reason. Oh, I remember why. This was just like the default in Sublime when I was coding in Sublime. The autocomplete for variables somehow just like was from the end. I don't know why. I guess it worked. But okay, distance. So what's the distance formula between 2 points? It's x1 minus x2 to the power of 2 plus y1 minus y2 to the power of 2. All of that square root. I guess, yeah. This formula. So what it does is it goes through all the other particles, and if the length, if the distance is less than the slider value, so they're close enough to like make a line. If distance is less than max and distance is greater than 0, I guess this is a check, so it doesn't check against itself. Maybe it should have just. There's probably a better way to do this, and then this is just random comment that I had. I don't know why. So if 2 lines are under this threshold, if two points are under this threshold distance, just make the girth of the line proportional to its distance. So stroke, it's going to map. It maps the distance, which is going to be from 0 to max, and then map it to a range of 250 to 0. So if the distance is 0, make it 255 thickness. If the distance is bright, like at the edge, like really far apart, make the girth like really small. And then oh sorry, this is actually for the color. If they're really close, make it white. If they're really far apart, make it dark. And this is for the weight. If they're really close, make it girthy. If it's really far apart, make it like not no girth at all. And then make a line between the 2 points. Okay, so dot connect. That's that function. So for every particle, so every second it's gonna go look at a dot and then say, okay, look at every other dot. Draw a line. So this is gonna be n squared complexity. Since for every dot we have to look at every other dot, that's like one length. The product of like another length, that's like a square. If you think about it. So okay, that's fair. Frame. This just calculates what the frame rate is. Um, cool. Then what we do is for every particle, if time mod frame is equal to 0. So this is just saying like, this is just a shitty like way of like updating only on the frame. So if frame is 1, time mod 1 will always be 0, because you can always divide anything by 1. So every time draw happens, it will update. But if frame is 10, it'll only update on the 10th frame. So it'll run a tenth of the time. It'll update a tenth of the time. And then, but it'll always display every particle. And display dot update is this dot x plus velocity. Oh, I guess I never gave an overview of particle, the object. So particle is an object. You pass in an x and a y. Particles that push, we make a new particle wherever mouse x is. So wherever our mouse is, it will make a new particle at that location, and then it'll add a random velocity minus 2, a random velocity, an x velocity, somewhere between -2 and 2. So it'll either be -2 or it'll be +2. So, and velocity is just the derivative of position. So velocity of x will be how x changes. If it's +2, it'll move 2 particles every time draw is called. If it's -2, it'll move 2 in the other direction. And Vy, same in the y direction. And then size will randomly be either be 2 to 10, 2 to 10. So when you initialize it, it'll have a velocity that it'll always have. The velocity stays constant, but the position changes according to the velocity. The size will always stay the same. So then when you update, you basically just add. This is very, very simple physics engine. Every second or every update, you add velocity x to x, and you add velocity y to y. So if the velocity was 1, 1, it'll move up 1x and then move up 1y. So it'll go in this direction. Yeah, and if y is less than 0, so if y is here and like we update it and then it happens to be up here, it says make y the height. So if a particle travels upwards, it'll just like appear to be here, like at the bottom. This is basically logic to like loop around the screen. If y goes over at height, make it go back here. If x is less than 0, if it goes past this screen, wrap it over here. And then same for x dot y width, wrap it around. And this dot display of a particle is just make it the color red and then make an ellipse or a circle of this size at the location. So yeah, that's the entire code. 114 lines, and then you get this. Hopefully I explained some cool, interesting computer science topics. And yeah, that's what it takes. See, the problem with n squared in the draw loop is that like n squared is like high complexity, and if it does every time, then like it'll grow pretty fast. How many computations it needs to do every second. So the more particles I add, the more computation it has to do in every cycle. That's why I capped it at 300 particles, because 300 to the power of 2 is 90,000. Yeah, so if there's 300 particles, it has to do 90,000 calculations every second. and this grows exponentially. So if you have 5 particles, it only has to do 25. If you have 6, it does 36. If you have 10, it does 100. If you have 20, it has 400. So it grows exponentially. That's your complexity class in a nutshell. So yeah, this is a cool little thing. This is what I did for a video. It was cute. I made a heart, and then I increased the length, then I increased the frame rate. Bam. The heart disappears. Anyway, I hope you enjoyed this video. Let me know if you want to see more of this content. It's your boy Moises. I'm out. Deuces.